Good day to you all! I'm Liandra and Naig, and in this video, I will be discussing about special products of binomials. But what are special products of binomials? Special products of binomials are special cases of multiplying binomials together. This is an important lesson because this allows us to expand polynomials by understanding key concepts and methods important in identifying these different patterns. Our learning objectives for today is to understand special products of binomials through the FOIL method, expand algebraic expressions involving special products, and answer problems involving examples of special products, which are the sum and difference of binomials, the square of a binomial, and the cube of a binomial. Before we start our lesson, allow me to share a brief recap about binomials. Binomials are a type of polynomial which consists of two terms. In the given expression, 2x plus 4, the terms are 2x and 4, which are separated by a positive operation. The variable here is x, the coefficient is 2, and the constant is 4. Here are some other examples of binomials. Can you identify the terms, the variables, the coefficients, and the constants? Moving on, let us define what the FOIL method is. The FOIL method is a method of multiplying two binomials where the partial products of the first terms, outer terms, inner terms, and last terms are added. In the expression, the product of the sum of A and B with the sum of C and D, the first terms are A, C, the outer terms are A, D, the inner terms are B, C, and the last terms are B, D. Combining them in accordance to the FOIL method, we have AC plus AD plus BC plus BD. Remember that the FOIL method is only used for multiplying two binomials. Otherwise, you'll end up being foiled. Now that we've discussed what the FOIL method is, let's move on to special products of binomials. In this video, we will be discussing about three: the sum and difference of binomials, the square of a binomial, and the cube of a binomial. Please take note that in this video, I might be phrasing the terms a little bit different. You may notice that I'm not reading them by their operations, but rather on the term signs. Because in special products, we are not focusing on adding or subtracting, but rather in identifying the different terms. So it's important to be specific with them. Are you ready? Let's move on to the first special product, the sum and difference of a binomial. The product of the binomial sum and difference is equal to the first term squared minus the second term squared. Here's how it works visually using the FOIL method. Find the first terms, outer terms, inner terms, and last terms. You'll get a squared, negative ab, positive ba, negative b squared. Now, look at the two middle terms, negative ab and positive ba. Those are the same terms, just with different signs. So, they cancel each other out, leaving us with a squared, negative b squared, which is a generalization for the sum and difference of a binomial. The product of the binomial sum and difference is equal to the square of the first term minus the square of the second term. Here's how it works visually using the FOIL method. Find the first terms, outer terms, inner terms, and last terms. We will get a squared, negative ab, positive ba, negative b squared. Now, look at those two terms in the middle. negative AB, positive BA. Those are the same terms, just with different operations. So, we can cancel them out, and that leaves us with A squared negative B squared, which is the generalization for the sum and difference of binomials. Try this example to test your knowledge. You may use the pattern above for reference. Still have trouble? You can remember it by finding the square of the first term, then finding the square of the second term, and then putting a negative operation between them. Here's how to answer the example that I just gave you. You may write the pattern for a guide. Write down the expression and find A squared negative B squared. A represents the first term and B represents the second term. In this binomial, the first term is 4t and the second term is 9. A squared will be 4t squared and B squared will be negative 9 squared. Simplifying this, we will get 16t squared negative 81, which is your final answer. Next, we have the square of a binomial. Simply put, the square of a binomial is the sum of the first term squared, twice the product of the two terms, and the second term squared. Here's why it works that way, using the FOIL method. There are two cases for the special product, and they differ in operation. In this case, we have a positive operation. Following the FOIL method, we will get A squared, positive AB, positive BA, positive B squared. Now combine those two terms in the middle, we will get A squared, positive 2AB, positive B squared. That is the generalization for squaring a binomial with a positive operation. Try this example to better test your knowledge on this. Are you still having problems? Just remember that you need to find the square of the first term, then the product of the two terms multiplied by 2, and find the square of the second term. Don't forget that all signs are positive. Here's how to answer the example that I just gave you. You may write the pattern for a guide. Write down the expression and find A squared, positive 2AB, positive B squared. A represents the first term and B represents the second term. In this binomial, the first term is 2x and the second term is 3. A squared will be 2x squared, positive 2AB will be 2 times 2x times 3, B squared will be 3 squared. Simplifying this, 2x squared will be 4x squared, 2 times 2x is 4x, times 3 is equal to 12x, and 3 squared is 9. 4x squared, positive 12x, positive 9 is your final answer. Here's the second case for squaring a binomial. Again, we have two of the same expression. So following the FOIL method, we will get A squared, negative AB, negative BA, positive B squared. Then, combine those two terms in the middle, and we will get A squared, negative 2AB, positive B squared. There you go! That's the pattern for finding the square of a binomial with a negative operation. Try this example to better test your knowledge on this. Remember the pattern, negative, positive. Here's how to answer the example that I just gave you. You may write the pattern for a guide. Write down the expression and find A squared, negative 2AB, positive B squared. A represents the first term and B represents the second term. In this binomial, the first term is 5f and the second term is negative 6. A squared will be 5f squared, negative 2ab will be 2 times 5f times negative 6, and b squared will be negative 6 squared. Simplifying this, 5f squared will be 25f squared, 2 times 5f is equal to 10f, times negative 6 is negative 60f. And negative 6 squared is 36, positive 36, because a negative times a negative is equal to a positive. Lastly, we have the cube of a binomial. This special product is much more complicated than the rest, but don't worry, I'll be here to discuss it for you. Since this is a cube of a binomial, we can write 3 of the same expression. And through following the FOIL method and through combining like terms, we will be able to get the formula a cubed, positive 3a squared b, positive 3ab squared, and positive b cubed. To further explain this, we must first find a cubed. Then, find the product of the first term squared by 3 and multiply it to the second term. Find the product of 3 and the first term, then multiply it to the square of the second term. And lastly, find the cube of the last term. Try this example using the formula given. Here's how to answer the example that I just gave you. You may write the pattern for a guide. Write down the expression and find a cubed, positive 3a squared b, positive 3ab squared, and positive b cubed. A represents the first term and b represents the second term. In this binomial, the first term is 2x and the second term is 3. A cubed will be 2x cubed. 3a squared b will be 3 times 2x squared times 3. 3ab squared will be 3 times 2x times 3 squared, and b cubed will be 3 cubed. Simplifying this, we will get 2x cubed, 8x cubed, 3 times 2x squared. 2x squared is equal to 4x squared times 3 is 12x squared times 3 is equal to 36x squared. 3 times 2x is equal to 6x times 3 squared, which is 9, is equal to 54x. And 3 cubed is equal to 27. Just like the square of a binomial, there are 2 cases to doing cube of a binomial, and they also differ in operation. The first one that I discussed was a positive operation. Now let me discuss to you cubing a binomial with a negative operation. We will just do the same things over again, write 3 of the same expression, follow the FOIL method, and the only thing that changed is the negative signs. Have you noticed the pattern? With operations with positive signs, all terms will be positive. But for binomials with a negative sign, such as this one, remember the pattern, negative, positive, negative. So the formula will now be a cubed, negative 3a squared b, positive 3ab squared, and negative b cubed. Try this example to better test your knowledge on this. Here's how to answer the example that I just gave you. You may write the pattern for a guide. Write down the expression and find a cubed, negative 3a squared b, positive 3ab squared, and negative b cubed. A represents the first term and b represents the second term. In this binomial, the first term is 2x and the second term is negative 3. A cubed will be 2x cubed. 3a squared b will be 3 times 2x squared times 3. 3ab squared will be 3 times 2x times 3 squared. And b cubed will be 3 cubed. Simplifying this, we will get 8x cubed. 2x squared is equal to 4x squared times 3 is 12x squared times 3 is equal to negative 36x squared. 3 times 2x is equal to 6x times 3 squared is 9. 6x times 9 is equal to 54x. And negative 3 cubed is equal to negative 27. 8x cubed, negative 36x squared, positive 54x, and negative 27 is your final answer. Now that we're done discussing about special products, are you ready for a quiz? Try these exercises to better test your knowledge on special products. Are you ready for the answer key? Here are the answers. Did you get them all correct? Great job! I'm glad that you've learned something. Before we end, allow me to share a brief summary of this video. In this video, we've discussed the FOIL method, wherein we add the first terms, outer terms, inner terms, and last terms. Remember, we only use the FOIL method in multiplying binomials. We've also discussed about special products, such as the sum and difference of a binomial, the square of a binomial, and the cube of a binomial. And for our success criteria, have you understood special products of binomials using the FOIL method? Have you learned to expand algebraic expressions involving special products? Answer problems involving examples of special products, such as the sum and difference of binomials, the square of a binomial, and the cube of a binomial? As always, thank you for watching this video. Remember that practice doesn't make you perfect, but rather practice leads to progress, and progress leads to mastery. This is Liandra and Naig, and see you next time!